Good evening, viewers. My name is Evelyn Namugwanya, and I'm presenting my work, first homework, C++ at UTC. As you see, number one necessitated us to find the gratuity and the total, but of which gratuity and the total you derive total from gratuity. For example, what I mean, to get total you must add subtotal plus gratuity. So how do we get subtotal? Like the subtotal, you prompt the user to enter subtotal, and you also prompt the user to enter gratuity rate. So you multiply the subtotal and the gratuity rate to get the gratuity, and to get the total you get subtotal plus gratuity rate. So the total is, okay, of course you declare the variables. I declare, like I did, the double gratuity rate and the int subtotal. I used the IO stream and the namespace std. So I'm going to compile here. So for example, in the question we have a sample of entering the subtotal of 10, then you enter the gratuity rate of 15%, which is the same as 0.15. Okay, that gives you the gratuity of 1.5 as stated here, and the total of $11.5. This can be any value is entered, but for this instance, for this circumstance, we used 15 and 10. Okay, so second number, we are supposed to find the sum of the digits given to us. I use the IO stream and std namespace. I have a main and I declared the values, the sum and the int value and the sum. Then I prompted the user to enter value between 0 and 1000. Then these if conditions help you to make a decision. If a condition is true, you display the information as you see here. If this condition is true, you display this information. If this is true, you display this information. If this is true, you display this information. For example, if the value you enter the user, the value entered by the user is less than 0, and the value is, if the value entered by the user is greater than 0, the value entered by the user is greater than 0 and the value is less than 10, meaning it's from 1 to 9, yeah? 1 digit value, meaning the sum is that value. If this is true, then the sum of digits is what? The sum of digits is the sum. The sum of digits is its number. Then if it is not true, it will go to this. Else, if it is not true, it will go to this. If it's not true, it will go to the invalid value. Try again. Let us run the program and insert the first condition, and we see. It's number 2. Okay, so we enter the value between 0 and 1000, but we want to test if this condition is proved. Then we shall display the information. If it's not proved, then we shall see what next. So value between 0 and 10, between value greater than 0 and less than 10. So it can be 9. When the value is 9, the sum of digits is this. Verifies this. In sum is equal to value. It's equal to that value. What happens if the value was a 2-digit value between the value is, meaning the value is greater or equal to 10 and the value is less than 100? It will do the same. It will add this and that. For example, if the value is 92, the value will be modulus 10, the right digit to get the right hand sign digit, that will be 2. Then also you divide by 10, you divide the same value by 10 to get the left digit. In 9 plus 2, that will give you 11. When it's a 3-digit value, it will go to satisfy this condition, which is value is greater or equal to 100 and value is less than 1000, meaning it stops. It is from 100 to 999. So what happens if the value is called, for as we were given in the question above, like the value was 932, meaning 932 modulus 10 to get the right hand value, we have 2 here. So when you get this 932 again, divide by 10 to get the left side value, it will give you 93. So when you get that 93, which is the try to modulus 10 to get again the right hand value, it will give you 3. When you get that 93 again and you divide by 2, reach 93, the same value here, what you do for the modulus to get the right hand value, it's what you do for the division. The value you do, the value you take, like you take for modulus is the same. So here it is 93 divided by 10, which will give you 9. So it will be 9 plus 3 plus 2, which will give you 14. Let's run the program and we see. This is number 3. No, it's number 2. Oh. Okay, so if we insert 932, that's 14. This one was our first reminder. The right hand value was 2. Then the second one, when you divide, then another one when you divide, like that. So that we came up with try 1, try 2, try 3. Okay, so you got number 3. Number 3. Okay, number 3, it's a financial application. What did it want? We want to get the value for the 6th month. Sorry, I was editing to test and see. That's why it has the 3rd month. So when we want to get the value for the 6th month, what do we do? Here I used this library, as you see, and the name space std. So in the question we were given this as the rate, as you can see, and plus an increment of 1. So I realized this is like a constant for every month. So that's why when I came here, I declared it as a constant. Interest rate is equal to 1 plus 1 is the increment per each month. Then this is the rate, interest rate. So I prompted the user to enter the monthly savings. In this case, we're working with 100. So when you enter 100, your 100 savings times the interest rate. So the amount of you get here, like the amount you get is carried to the next month. Yeah? When it's carried to the next month, here it's this amount here plus this savings times the interest rate. It gets you the value for the 2nd month. That's what we do for also the 3rd month. The amount from the 2nd month is brought here plus the savings. You execute this addition, then you multiply by the interest. Yes, there are these brackets because there's addition first, then the multiplication, right? Yes, then after the account value after the third month. Let us first see the account value after the third month, then we shall go for the sixth month, because the third month is right here. Okay, let us just go to the sixth month as I was supposed to do. I put that because I was testing. So sixth month, it's amount 5, as you can see. So it's amount 5. You save. So when you come here, so savings, they say let us see whether you save 100. The sample space, like it's 100. The sample money, sample dollars, $100. So if it's that, after this 6th month, the value on the account will be 608.818. Okay, so we go to number 4. Number 4, we are supposed to calculate the roots of a quadratic equation, and I used, what is special with this, I included the math library. That is because I had to use the square root of the discriminant. So I declared the double AB and C. Remember, if it's double ABC, you can also enter an integer. It is okay, because an integer can be double. 1 can be 1.0 or something. It's okay. So now, please see out. I prompted the user to enter ABC, as you're about to see after me compiling. Then I declared and initialized the discriminant as B. This was given to me in the question, as you've seen above. It's B squared. This means B squared. So the discriminant is, this formula helps us to get the discriminant. Okay, which discriminant we are going to use to find the roots of the quadratic equation, root 1 and root 3. So if the discriminant got here is negative, if the discriminant is negative, if the discriminant is, it is, oh, this is supposed to be, if the discriminant is greater or equal, yes, that is right, the discriminant is greater or equal to 1, meaning it will be, so that is it. Let me control save and then run the program. Yeah, if it's, then it will give me 2 roots, root 1, root 2. If the discriminant is equal to 0, it will give me 1 root, meaning if the discriminant is lesser than 0, it will give me no roots. It has no roots. Okay, it won't have any root. So let me run it and see. This is number 4. Oh, oops, this is what, number 4. Number 4. Okay, seems I've not run it before today. Compile number 4. Okay, so when I enter 1.0 and 2.0, then 0.0, you see the discriminant is 4. The equation has 2 roots, because discriminant, when if the discriminant is greater or equal to 1, okay, you get? So it has 2 roots. So we have another test. So if A is equal to 1 and B is equal to 0.0 and C is also equal to 0.0, So the discriminant is 0. It will have one root. Okay, so if they, now we are looking for when the discriminant has no root. So that is a is equal to, if we say a is equal to 0 and b is equal to 1, even say is equal to 1, it doesn't matter whether you put a dot to make it a double as declared, or an int can be both. So the discriminant is 1. The equation has 2 roots. You remember, if the discriminant is less, eh? If the discriminant is greater or equal to 1, so now the discriminant is 1. Okay. So now find out when let me see, like 3, 4, 4, 0. So the discriminant is 16. It has 2 roots. Okay, so now what are we finding out? If I have a is equal to 0 and b 0.1 and c is equal to 2.0, the discriminant is 0.01. Equation has no real roots. Okay, so this is it. This is it. I'll be very grateful if you learned from it. Subscribe to my channel. Thank you. Bye bye.